All right, here we go. Last lecture of the semester. Take notes, and then at the end, we can all jump for joy. Okay, let's see here. Okay, so 8.5 deals with solving quadratic and other nonlinear inequalities. So you all know how to solve a quadratic equation. So we're going to be looking at how do you solve a quadratic inequality. Okay, and then we're also going to look at rational inequalities. Okay, so take notes. 8.5. Quadratic and other nonlinear inequalities. All right, so we're going to start with quadratic inequalities. So there are definitely steps that you need to follow. Okay, so the first step you need to do is make sure you set the inequality to 0. If it isn't, okay? All right, the next thing you do, once it's set equal to 0, then you're going to find the solutions to the equation. So even though it's an inequality, here on step 2, what you're going to do is you're going to pretend it's an equation and solve it. And we know how to solve quadratics. So you can use factoring here, or you can use quadratic formula. So you can factor, or you can use quadratic formula. And it's really interesting because students will stop on step 2 and think they're done, but this is not it, okay? Step 3. So once you find those solutions are the critical numbers. So solutions to the equation are what we call critical numbers. So what you're going to do here is you are going to plot the solutions on a number line. So like if you, like let's say you factored over here and you got x plus 3 and x minus 5. Okay, so then over here, so the solutions would be x equals negative 3 and x equals positive 5, right? So then you would go over here, 1, 2, 3, negative 3 is here. You would plot 1 there, and 0, 1, 2, 3, 4, 5. 5 is over here, so you would plot over here, right? So you would plot the points, okay? All right, so plot the solutions on a number line. Now, if it's if strict inequality, here, let me do this. If strict inequality, so if you have this or this, then use open circle. So like if you have this, you just do that, okay? If if you have this or this, less than equal or greater than equal, then use closed circle. Okay, so if you have that, right? If you have one there and you have one there, then you would use closed circle. Okay, and that's if you have the less than equal or greater than equal. These are strict inequalities. They cannot equal, so leave them open. Okay, all right, so you find your solutions, use factoring or quadratic formula, and then you plot those solutions on a number line and use open circle or closed circle. Okay, and then after you do that, then you are going to test each region. On the number line. And shade accordingly. Okay, so shade accordingly. And then the last step, write your answer. You can use set notation. You can use interval notation. So let's go with interval notation. So write your answer in interval notation. That looks like an N, M. Okay, interval notation. So for example, if you have this, right, and suppose that we have open circle, and let's say this is at -2, and let's say this is at 3, open circle, and you're shaded like this, then that's -infinity to -2, union 3 to +infinity. Okay, so that's interval notation. Okay. All right, so those are the 5 steps. So these problems can take a little bit of time. So, and like I said, oftentimes students will stop right here at step 2 and they think they have the answer. Okay, so just because you factor and you get some numbers doesn't mean you're done. Okay, so that's really just the beginning, because you take those solutions and you plot them. And then what happens is, if you have those two solutions, then now you have 3 regions. You have this one, you have this one in the middle, and you have this one over on the right. And so what happens is you have to test each of those regions on the number line and shade accordingly. Okay. And then whatever answer you get, you have to make sure you write it in interval notation. Okay. All right. So let's go ahead and take a look at an example. All right. So let's take a look at this one. Let's go ahead and solve this inequality, x squared plus x less than 6. Okay. So the first step says to rewrite this in set to 0. Okay. So x squared plus x minus 6 is less than 0. Okay. So we have it set to 0, and then it says to treat it like an equation and solve. Okay. So I'm going to go ahead and go off to the side over here. Pretend it's an equation. And I'm going to go ahead and solve this. I'm going to see if it's factorable. If it's not, then I'll use quadratic formula. Positive, negative, 3 and 2. Yeah, 3 here and 2 here. And that will give me +1 for the middle. So I get x equals -3 and x equals +2. Okay. And again, this is usually where students will stop. Okay. That is only the beginning. Now we have to plot those Now we have to plot those on a number line. -3. I'll pretend -3 is way over here. And this is a strict inequality, so I'll keep it open circle. And then +2 over here. And again, strict inequality, so I'll keep that open. So now I have these three regions. This is region 1, this area over here. This area in between is region 2, and this is region 3. So we have 3 different regions, and what I have to do is I have to check. I have to check to see if I can pick any number. Okay, I'll check each region one at a time. And what I do is I can choose any number in the region, plug it into my inequality. I could use this one or this one, doesn't matter. And I have to see if when I plug that number in, I have to check to see if it satisfies the inequality. In other words, I have to check to see if my result gives me something, a true statement or a false statement. Okay, so here, -3, so I have to pick something on this side of -3. So again, you can choose whatever you want. I like to go with the smallest numbers possible. So I'm going to check by using x equals -4. Okay, x equals -4 is in this region. You can choose -4, you can choose -5, you can choose -7, you can choose -83, you can choose -9.127. But why would you, right? Okay, so I'm going to choose x equals -4. And what I'm going to do is I will plug it into here. You can use either one. I don't know why I prefer this one, but it doesn't matter. Either inequality is fine. So I'm going to plug it in over here. Okay, so -4 squared plus -4 minus 6. And I want to see, will this be less than 6? So let's check. -4 squared is +16 plus -4 minus 6. 16 minus 4 is 12 minus 6. And 12 minus 6 is 6. 6 is less than 6. That is false. Okay. So that is false. 6 is not smaller than 6. 6 is equal to 6. Okay. All right. So since it's false, don't shade. Okay. So false means don't shade. Okay. So we're not going to shade that area. All right. So we'll move over to this middle region. I get to choose a number over here and check to see if it satisfies the inequality. So we're going to go ahead and check here. And we're going to check by using a number between -3 and 2. So you can choose like -2, -1, 0, or 1, or 1.5. Okay, so anything between -3 and 2. I am going to choose 0. Okay. And I will plug it into this inequality. Again, you can use the original one. You can use this one. Okay, so 0 squared plus 0 minus 6, is this less than 6? So I get 0 plus 0 minus 6. I get -6 is less than 6. That is true. -6 is less than 6. So here I will shade. So I will shade this region. Okay. And then I have this third region to check. You have to choose a number in this region. So you can choose like 2.5, you can choose 3, 4, 5, 6, 7, 1,000, 2 million. Okay. But I will use 3. Okay. So 3 squared plus 3 minus 6 is less than 0. Let's check. Is it less than 0? So 9 plus 3 minus 6. 9 plus 3 is 12. 12 minus 6 is 6. 6 is less than 0? Nope. That is false. So we don't shade this region. Okay? So this is our final answer right over here. And it says here, write your answer, test each region on the number line and shade accordingly. We did that. Now it says write your answer in interval notation. Okay, so the way I write this, -3 to +2, but not including -3 and not including 2. Okay, so we only see one region that is shaded, so I only have one interval. Whereas here, there were 2 intervals, so I have 2 regions that were shaded, so I have 2 intervals. This one to represent that part, and this one to represent that part. But if you only have one region, then you should only have one interval. Okay? If you have 3 regions that are shaded, then you should have, well, it's hard to see it here, but if you had, like, say, not 2 critical numbers, but let's say we had a third, so you have 4 areas, and let's say 3 of the 4 areas are shaded, then you would need 3 intervals. Okay? Okay, let's go ahead and take a look at another example. Solve x squared greater than equal to -x plus 12. Okay, so first thing, set it to 0. So x squared plus x minus 12 greater than equal to 0. Okay, go off to the side, treat it like an equation, and solve it. Plus minus, so 3 and 4. 4 over here, 3 over here to give us positive 1x for the middle term. Okay, so x equals -4 and x equals 3. Again, don't stop here. These are just your critical numbers that you're going to plot on your number line. Okay? All right, so we have one over at -4. And this is greater than or equal. So I'm going to go ahead and use the closed circle, -4. And over here, we have +3, also closed circle. Okay, so I have my 3 different regions. So I'm going to go ahead and check. And here I'm going to use -5. Again, you can choose whatever number in this region to check. Okay. All right, I will use this inequality. You can use that one, that's fine. I'm going to use this one. So -5 squared plus -5 minus 12, and we want to know, is this greater than or equal to 0? So here I get positive 25 minus 5 minus 12. Here I get 20 minus 12. 20 minus 12 is 8. Is 8 greater than or equal to 0? Yes, that is true. So we will need to shade. Okay. Okay, middle region. I will choose 0 is between -4 and 3, so I can choose 0. All right, plugging into that inequality, 0 squared plus 0 minus 12. Is this greater than or equal to 0? Well, let's check. 0 plus 0 minus 12. Nope, because we get -12 is greater than or equal to 0. That is false. So don't shade this area. Okay. And we have to check this last region. I will use x equals +4. So let's see what we get. 4 squared plus 4 minus 12. Is this greater than or equal to 0? 16 plus 4 minus 12. 16 plus 4 is 20. 20 minus 12 is 8. And that is true. 8 is greater than or equal to 0. So we will go ahead and shade this area. Okay, so we have these two regions. We have two regions that are shaded. So I need two intervals to describe the two regions. So this region is negative infinity to negative 4. Okay, so negative infinity to negative 4 bracket. And then this region over here is positive 3 to positive infinity. So positive 3 to positive infinity. So this is how you would write your answer. Okay? Okay, so those are quadratic inequalities. Let's take a look at rational inequalities. They're very similar, but there are some little things about it that you have to keep track of. Okay, so rational inequalities. So similar setup. Set it to 0. Okay. And your critical numbers this time, your critical numbers will be the solutions. Okay, so let's write this down. Critical numbers will be the solutions to the equation. Okay, so this is basically when where the numerator will be 0. Okay. And then it will also be where the where it's undefined. Okay, so where it's where the rational, here I'll say function so we don't have to write so much, where the function is undefined. So that's where the denominator equals 0. And so there, that one, you will never have closed 0, closed circle. Okay, never, because the one that makes it undefined will never be part of the solution. Okay. All right, so let's take a look. And again, you just check each region. Shade, and then write answer in interval notation. Okay. All right, so let's take a look at this one. Let's go ahead and solve this. X squared plus x minus 2 over x minus 4 greater than or equal to 0. If you have two fractions here, you'll have to do what you did when you learned rationals, and you'll have to add them. Okay, so you want only one fraction over here. Okay, so we want where the numerator equals 0. So let's go ahead and take the numerator, set it equal to 0. Let's see if it factors. X plus minus 2 and 1. So x equals negative 2, x equals 1. Okay. And then we also, this is the one from the numerator. And then we want the one from the denominator. Okay. So x minus 4 equals 0. So x equals 4. And remember, the one that comes from the denominator never gets closed circle. All right, so we have one at negative 2. And since this is greater than equal, this will be closed circle. We have one at 1, closed circle. But the one at 4 comes from the denominator, and that will never be closed circle. Okay, the one from the denominator, right? It came from over here. The one that comes from the denominator will never be closed circle. Okay, 1, 2, 3, 4 regions. Okay, over here. So let's go ahead and we will check. Okay, so let's go ahead and check negative 3. X equals negative 3. I'm going to move over here to the left. Okay, so because it looks like I'm going to need some room for the other regions. Negative 3 squared plus negative 3 minus 2 over negative 3 minus 4. And we want to know if that's greater than or equal to 0. So let's check. 9 minus 3 minus 2 over, this is negative 7. Okay. 9 minus 3 is 6. 6 minus 2 is 4. So we get negative 4 over 7. Negative number is not greater than or equal to 0. So this is false. Okay, so don't shade. Don't shade this region. Okay, what about here? What are we going to check? Do we have 0? Yeah, 0 is always nice. 0 is easy to work with. All right, 0 squared plus 0 minus 2 over 0 minus 4. Is that greater than or equal to 0? We get negative 2 over negative 4. Oops, negative 4. And that becomes positive 1/2. Positive 1/2 is greater than or equal to 0. So that is true. So we will shade this region. Okay. All right, let's check this region. So I like 2. Again, I like small numbers, so 2. Okay, so 2 squared plus 2 minus 2 all over 2 minus 4. Is this greater than or equal to 0? Let's check. 4 plus 2 minus 2. 2 minus 4 is negative 2. And so we get 4 over negative 2. So that's a negative number. That's negative 2. So this is false. So no shade. Don't shade. All right. We need this area right here. I'll choose here. I forgot to tell you what I was checking. I checked x equals 2. All right, over here in this region over here, I will use 5. All right, let's check. 5 squared plus 5 minus 2 over 5 minus 4. Is this greater than or equal to 0? Let's check. 25 plus 5 minus 2. 5 minus 4 is 1. So that's 30 minus 2 is 28. So yes, this is true. So we shade. Okay. All right, so we have these two regions. So I have to have two intervals, one for this region, one for this region. Okay, this region, bracket, goes from -2 to 1, bracket. And this region over here starts at 4, parentheses, not bracket, to positive infinity. Okay? All right. Excellent. So that's how you do inequalities. So just make sure you get the numerator solutions, plot them, get the one from the denominator. If the denominator doesn't have one, then you're fine. You don't need to plot them. Okay. But if there are any solutions from the denominator, you have to plot them. And remember, they will never be closed circle. Okay. These are closed circle because we have the greater than equal. This is not the strict inequality. Okay. All right. There's one more thing here that we need to cover, and that's graphing the parabola, graphing a parabola inequality. Okay. So graphing inequalities, into variables. This will be very similar to when you graph. Do you remember? Here, don't copy this down. But do you remember when you had these, and then you did the shading? You did a checkpoint, and then if it was true, then you shaded. Okay, it's going to be very similar, but instead of lines, you'll be doing it with parabolas. Okay. All right, so let's just jump into an example here. Okay, so let's graph y is less than or equal to x squared minus 4. Okay, so this is just a parabola. You might have to use what you learned about graphing parabolas in the last section. You'll do it here, where you have to find the vertex and an extra point. But you just did a whole section on that, so I won't go over one of those kind. I'll go over this kind where you just shift down 4 units. Okay, so remember these are the 3 original points, but now they're going to get shifted down 4 units. 1, 2, 3, 4. So that goes there. 1, 2, 3, 4. And 1, 2, 3, 4. Okay. Now, if you have this or this, then you will have a solid parabola. Okay. If you have this or this, then you will have the dotted, just like dotted line, solid line. Okay. All right. So this one is the less than equal, so this will be solid. And now you get to choose a point either inside the parabola or outside the parabola to check, to determine where you shade. Okay, so if 0, 0 is not on the parabola, then go ahead and choose it. Okay, so I'm going to choose 0, 0 and plug it in here. Plug 0 in for x, 0 for y. If it turns out to be true, then I shade inside the parabola. If it turns out to be false, then I'll shade outside the parabola. Okay, so let's go ahead and check. We're going to take that checkpoint 0, 0 and plug 0 in for y and for x and see what kind of statement we get. 0 is less than -4. That's false. So it's false for 0, 0, so don't shade there. So we're going to have to shade outside. Okay, so it's very similar to graphing linear inequalities. Okay, so that is it. If you have any questions, make sure you message me, Keep up with the homework. This is our last lecture for the semester. All right. Good job, you guys.